Okay guys, here let's go through the last part of the notes, page 4 through 6. The top of 4 talks about a second approach, the p-value approach. That is, right now, in the classical approach, we compared z-scores. And our z-score was between the required or less than or more than on the one-tailed test. We made a conclusion or not. P-value, instead of comparing z-scores, it takes the z-score for what happened and converts it to a probability and compares it to alpha. So alpha is basically your rarity, right? If you have a 0.05 alpha, that means you want to catch 95% of results and say they're reasonable, which means 5% are unreasonable. So if you look at your z-score and you find the probability that z is greater or less than something, and it's less than that 0.05, and you're like, well, whatever happened in my sample was more rare than a 5% chance, so therefore that's evidence against the null hypothesis. So if we recall to the last problem we did, where we had the z-score of 2.15, let's look at what this would have looked like in a probability. The probability that z is greater than 2.15. So if you look at the chances z is bigger than 2.15, remember for the right side, that's 1 minus the z-score of 2.15, which is 1 minus 0.9842, which is 0.0158. So this is the p-value because it's the probability of you taking that sample of that size and getting a z-score of 2.15 or greater, which is only a 1.5% chance, or 1.6%, about 2 out of 100 if you round up. What does that mean? Well, it's less than a 5% chance, so that would allow you to say there's evidence against the null hypothesis, which is the same conclusion we got when we were doing it the other way. So I'm going to skip number 1 on page 5. I think you guys can handle determining the critical value. So what I'm going to do here is do number 2. We're going to call it method 1, which is the classical approach, and method 2, p-value. The only thing that changes between these two methods is what you're comparing. So that's probably step 4. And the second way to do this problem is number 5 on page 6. So I'm going to note that. So first, we always have to write our 2 hypotheses. The word problem is, in a Gallup poll, a random sample of 805 adults were asked to identify their favorite seat when they fly, and 442 chose window. Use a 0.05 level of significance to test the claim that the majority of adults prefer a window seat. Okay, so majority prefer means if we assume that they don't prefer, then H naught would be P equals 0.5, because that's a 50% chance, so that's not a majority. But what is H1? I should put colons. So that P is greater than, because for a majority to prefer something, that's how it works. It has to be greater than 0.5. Now, our alpha, our significance level, is 0.05. So this is where I have to calculate the z-score for the classical approach. So z equals, I need a ratio for my adults. It's 442 over 805. What is 442 divided by 805? Let's see. It is 0.549. Okay, so what do I do with that? This is where I do 0.549 minus 0.5 over the square root of 0.5 times 0.5, or 1 minus 0.5, over, our sample size was 805. So now I will put that into the calculator. What have you got? I show it as 2.78 because this is z-score. Now, since my alpha was 0.5, what is my critical value for 0.5 or 0.05 when it's a one-tailed test? So that means I can use that whole margin at the top, and this ends up being the critical value of 1.645. To find this, if 5% is above, in the z-table you can find where 95% is below a value. It's right between 1.64 and 1.65. But either way, what do we know? That my z-score, 2.78, is greater than 1.645, which means it's more standard deviations away than the cutoff point, which allows us to conclude what? There is sufficient evidence to conclude that the majority of people prefer a window seat. So how does this look different if we do the p-value approach? First off, everything is the same at the beginning. That won't change. Our ratio is not going to change. Our alpha is still the same. But we're not going to convert it to a cutoff value because we're only comparing percentages. Our z-score is still the same. Still 2.78. But I need to convert the z-score instead to a probability. So what is the probability that z is greater than 2.78? This is where you go to the z-table and you'll find down the left and top side where 2.78 is. And I show it as 0.9973. Would be the probability that it's less than 2.78, so I have to do 1 minus 0.9973, which is 0.0027. Okay, so the actual chances of this are 0.0027. Is that rare? Yes. So is 0.00, is the probability of it occurring less than the probability of alpha? So in the z-score, we're often looking for it to be bigger than to reject the null hypothesis. Here, for the p-value, we're going to look for it to be less than to reject the null hypothesis. So what does this mean? It's still the same conclusion. There is sufficient evidence to conclude that the majority of people prefer a window seat. Now quickly, I know I skipped number 3 and 4 on page 6. I think you guys can handle that yourself. It deals with looking at the z-table and figuring some things out. Just remember on number 4, because it's a two-tailed test on number 4, you're going to have to double the answer that you get because you have to count for the left side and the right side as both being part of your answer. Anyway, that's enough for 10.2. We have just 2 more sections left. I may make the test 7 through 10, and then we'll have chapter 4 afterwards. I'm gonna wait and see. And that's it.